Welcome all to the event where we have our first Web3 events after 2017. If you guys are still with us since 2017, I guess you guys probably know that we hosted one before with Hybrid, which is Access Malaysia. And then it was quite a while after we started another round of blockchain series. So this is our first one in 2022, and hopefully we can have more upcoming. So welcome everyone on the Saturday afternoon. Thanks for being with us. We are going to explore about, so let's go through our agenda of the day. But before that, a little bit of background on Women Who Code. Sorry. We are a NGO that is founded in Kuala Lumpur chapter on 2014. Women Who Code is actually founded in San Francisco, which that's our HQ. And then we have a lot of chapters all over the world. The mission is to empower women in technology. But our events, we don't really limit to just women. We actually also encourage men and our allies that support the entire mission to join us in the events and workshops that we host. So the workshop and the event that we host are very much related to technology. So we have workshops on software engineering, we have panel discussions about product management, and we also even have we also even have workshops on data sites such as SQL, data analysis with Excel and Power BI. That's Women Who Code. And if you would like to know more about our events, get updates on the upcoming workshops, you can join the following social medias. And if you are keen to be like the first tester of our event or even volunteer in some of the events, you can join our Telegram volunteering channel, which we will constantly post some of the opportunities that you would be interested in. Okay, so today, it's very simple. We won't take too much of your time introducing ourselves. After this, I'll be passing it over to Elson, which is our speaker, to introduce about himself and also the agenda of the day. But high level, we are going to have a bit of presentation to just give an introduction about blockchain, how is it related to Web3, and then how crypto comes in the picture, right? And then Elson will then share his screen and do a very quick demo on how to build a simple dApp. Because of the time constraint, it would not be like a step-by-step walkthrough. We have shared the GitHub link and also we have shared Elson's GitHub link, and I also put out like what are the requirements do you need to get yourself ready if you want to follow through the workshops. But bear in mind that this is not it is not a step-by-step guide, and you can just watch at the moment. If you are interested to really build it and get some hands-on, you can comment it in our feedback, and we can look into hosting another session which is dedicated for hands-on, right? After that, we will leave the Q&A sessions at the end. You feel free to drop your messages into the chat, and we can pick it up as and when we have that sessions. So after that, we will then do a wrap-up, right? So throughout the sessions, we have already enabled the setting where you are muted, because we want to make sure that Elson is given to the floor to explain about the entire mechanisms. If you have any questions, feel free to raise your hand. We can unmute you during the Q&A, or you can drop your message in the chat, and moderator, which is me and Mavis, will be picking up. Right. So that'll be it. I think I will then pass it to Elson.
Okay, cool. Okay, thanks, Brianna. Okay, let me share my screen. Okay, can you see my screen, right? Okay, thank you, Brianna and Mavis, for inviting me to this talk. So this will be an introduction to blockchain and Web3. So let's go through a bit on our agenda today. So as Brianna mentioned, it's more on the understanding introductions to blockchain and how do we relate blockchain to Web3. And also we'll be going briefly about the development environment, what are the tools that you need, and also a simple walkthrough, a demonstration of a decentralized app. So the language we will be using is Solidity and ethersJS. So you will learn more about this later on. Okay, next. So a little bit about me. So I'm the head of technology and director at Nidex Solutions. So Nidex Solutions is a software house based in Subang Jaya, Malaysia. And I'm also the founder of CryptoKaki. So CryptoKaki is a techies group for blockchain, Web3 related stuff. So if you are interested in anything related to blockchain, Web3, you can always visit our group. It's on Facebook. And for myself personally, I'm a full stack web developer and AWS solutions architect. So I've been developing on the web for at least, I guess, 10 years, and just started exploring Web3, decentralized app, all those stuff last year. So I have attached a few links to my Twitter and also the CryptoKaki community on Facebook. So later on, Brianna will share these slides with you guys, so you can click on the link. Okay, so let us start with blockchain itself. What the hell is blockchain? So we have heard a lot of things about Bitcoin, Ethereum. Currently, the market is crashing as we know it. But so to understand blockchain itself, you need to understand what's the current scenario we are facing in real life. So if you were to transact something, right, transact funds, you need to go to the bank. So bank will act as a central authority to verify your fund transfer to another party. So blockchain itself is considered as a decentralized database, or you can call it as distributed ledgers. So what does this mean? Basically, its mission is to remove any central authority, spread this transaction verification across computers, a network of computers across the world. So this is the underlying technology for Bitcoin itself. So this Bitcoin, this blockchain promises transparent public ledger. So everyone can view a public ledger. That means all your transactions is visible and can be verifiable by anyone. So this is basically how the blockchain comes back. But we need to understand how does the transactions go through first before we can get a better picture on how blockchain works. So here I have an illustration of how transactions being verified in the blockchain itself. So if you refer to the screen here, so if someone, for example, you initiated a transaction, you want to send funds across to someone else. So every computer on this blockchain network is called like a peer-to-peer network. That means there are computers spread around the world that acting as a nodes, what we call it as a node. They're able to see this transaction request. So each of these nodes, right, they will start to verify your transaction. Everyone needs to agree on the transaction. Is it valid or not? Does it contain legitimate data? Then only it will start creating a block. So what is a block? So block is something that contains information about your transactions. So you have your sender data, receiver data, the amount of funds you want to transfer. So in this case, the funds will be cryptocurrencies. Then after that, once the block is created, right, it will be joined into the chain. That's how the whole blockchain will coming from. So once all these processes are completed, right, the transaction is considered done. All the nodes in the network will have the same copy of the transaction. So this is a high-level overview. It's a bit technical, but let us go through another example. Okay, here's an example of a real scenario. So David, this guy, want to send 5 Bitcoin to Sandra. So on the right, you can see a network of nodes. So you can assume nodes as like a computer that has a ledger. So if you do not understand the word ledger, ledger is like your account book. Account book, we have records of everyone's balances. So you can see the account book, you have Mary, John, Sandra, everyone else. So we know their balances is like this. So when David wanted to send 5 BTC, 5 Bitcoin to Sandra, David's account should go down by 5 Bitcoin, then Sandra's account should be increased by 5 Bitcoin. So you can see the green nodes here is already modified. So when the message go through the network, the green node is already modified. That means it already verifies the transaction data and pass it to the subsequent nodes. So the subsequent nodes will start verifying the data. Once everyone verify and agree this transaction is okay, then everyone will update their ledger to the latest balance. So the decentralized is working like this. Whenever a single node drop off, right, everyone else have this account book. Not just one guy has this account book. So the account book will always be available unless the whole network fell down, the whole network got destroyed or something. But it's very unlikely to happen because there are thousands of computers out there running this. So you heard of mining, right? Those nodes, those people operating these kind of computers are called miners. So they basically mine your transaction, they verify your transactions. Okay, so far this is how the propagation works across the network. Hopefully you get a glimpse of how the blockchain currently works. We won't go too deep about the technology itself, but this is on the surface level. Okay, so we have this Web3 already. So Web3, what is it? Let us look back first. We have Web 1, Web 2. So Web 1 itself, if you remember, during the early 90s, early 2000. So we have all this Netscape browser. Netscape browser only allow you to browse static sites. That means, for example, if the site is only read only, that means there's nothing else you can interact with it. Basically, it's just plain text. You click on hyperlinks, lead you to another set of plain text. So everything on Web 1.0 is consume basis. You consume the data from the internet. Then moving on forward to early 2010, we have everything we are using currently. We have Facebook, we have Airbnb, we have Uber. All of these are, you can say, have interactivity with them. So if, for example, on Facebook, you create a status, you posted a status. So this status will be sent to Facebook servers. Then when you wanted to read this status, or the status being displayed to your friends' feed, right, is grabbing from Facebook servers as well. So there's two-way interaction in Web 2. And all of your information is stored on a central server on Facebook servers, Facebook data centers. It's similar across all the applications that we are using. So where we are now is at Web 2. Then moving forward, there's this Web 3. So Web 3 term is still very, very new because we are still in the phase of transitioning to there. You can say we are in like Web 2.5. So Web 3 promises a decentralized data architecture. That means there's no central servers like Facebook holding all your information. There's no central servers like Airbnb holding all your records. So everything will rely on decentralized networks. That means our underlying technology will be our blockchain. So cryptocurrencies and blockchains come into play during Web 3.0. So later on, you'll see what are we going to use for this Web 3.0 development, our decentralized apps. So there's one more slide to explain more on Web 3. So Web 1, as I explained, is only read. Web 2 is more on read and write. So you have interactivity with it. Then Web 3 is read, write, and you own the data. So Web 3 promises that, okay, you own your own set of data. The only thing you need to sign in is your wallet. So wallet will represent your identity. You can be just wallet address. Wallet address basically is your identity on the Web 3 world. So yeah, that's it. Web 3 is read, write, own. You own the data. Okay, so let's fast forward a bit. So in this workshop, I would say, we'll be using another blockchain. It's called Ethereum. So Ethereum is like the second largest market cap after Bitcoin. And you'll see Ethereum itself is, you can say, opens up more opportunity to build on a blockchain. Bitcoin itself is like just a cryptocurrency. There's not much applications can be applied on it. But Ethereum promises a more open ecosystem for us to build decentralized apps on it. So Ethereum itself was conceived by this guy called Vitalik Buterin, back in 2013. Then as Ethereum grows, it allows anyone to deploy permanent and immutable decentralized application. That means once we deploy onto the network, right, we cannot take it down. We cannot pull it back. This is the beauty of decentralization, which users can interact with your decentralized app. So the native coin, Ether, and you can basically develop applications on it using something called smart contract, which will be compiled into EVM bytecode. Later, we'll be covering more on smart contracts and this EVM stuff. Okay, so there's basic overview of Ethereum. It's another blockchain. It's the second largest one after Bitcoin. Then, yeah, smart contracts. Okay, smart contracts is very crucial for your Web3 development. So smart contract itself is like a self-executing contract. So I give you an example. So whenever you purchase a house, so you have a lot of loan agreements to sign, your SPAs, how do you make sure the funds transfer from party A, from you to party A, or maybe party B? So all of these are very manual processes. Imagine all of these are self-executing. That means once you put in your, confirm your transaction into the smart contract, it will execute. It knows that, oh, this 30% goes to party A, this 40% goes to party B. So everything is self-executing. So smart contracts can be deployed onto Ethereum blockchain or any EVM chain. So what are these EVM chains? So there's a lot of other blockchains that supports Ethereum virtual machine. So any blockchain that support EVM can be able to deploy Ethereum-based smart contracts. So smart contracts, there's a lot of popular languages for coding this smart contract, but the major one, the most popular one, and the one we will be using today is called Solidity. And again, smart contracts are immutable. Once you deploy onto the blockchain, right, you can never pull it back. So that's why there's a lot of security issues, security breaches that you hear online on the news, that someone's dApp got exploited and millions of dollars were lost because they do not carry out very rigorous audit on their code, their Solidity code, and also they do not care much about the security. So once you deploy, it's always on the decentralized network. You can never pull it back. So there's one point you must always remember. So coding is Solidity, developing smart contracts, you must be very careful. Okay, moving on. So the development journey. So what we will be doing today. Let us look at what normally a dApp development journey looks like. dApp is decentralized applications. So first thing, you need to develop your smart contract. Smart contract, as mentioned just now, we develop it in Solidity language. Then we develop a web application. So web applications can just be HTML static sites, but you need to import in the JavaScript library, later we'll be introducing, to interact with your smart contracts that is deployed onto a network. So the network itself is either on the testnet or the local network or the mainnet. So there's three here. Local network is run by this tool called Hardhat. Then testnets, there's a lot of testing network. It simulates the real main network of the Ethereum. So one of it is Robston. After you develop all this, right, normally we will test it on our local blockchain environment first, then only we deploy to testnet. Once we deploy testnet, we can start testing online. You can also deploy your web application there and share it to your friends or your testers, saying, oh, you can test this, but make sure you are on the testnet network. Once testnet testing is completed, we can go for launch. We launch up onto the mainnet, which is publicly, we can use it already. Okay, right? Okay, let us go into the wallet section. So MetaMask is a Web3 wallet, you can say that, call that. So MetaMask itself is like a browser extension. You can download it for Chrome or Firefox. I think there's other browsers as well. So this is the most popular wallet, crypto wallet for your dApp development. So there's also Wallet Connect, there's other types of wallets. Different blockchains have different wallets, but MetaMask supports all EVM blockchains, I mean any Ethereum-based blockchains. Okay, so during this talk, we won't be going through how do you fund your MetaMask with cryptocurrencies, how to fund it with Ether, and changing your correct network. Those resources can be easily found online, so you can refer that. Okay, the tools, yep. So Solidity for smart contract. For JavaScript library, we will be using something called ethersJS. And for our web standard HTML, CSS, JavaScript, for our local development environment, right, we are using something called Hardhat. So Hardhat is a Ethereum-based local development environment. It's very it's a full suite of environment. It has its own local blockchain. It can help you to compile your Solidity. It can also run test scripts, everything you need for a local development for your decentralized apps. Okay, so yeah, a little bit example on the apps that we built, the apps that on Ethereum. But the most famous one, I think you guys seen these monkey photos, right? Those are called NFTs. NFTs is considered as a, you can say like a decentralized app already. It's one of the application. So NFT stands for non-fungible tokens, and non-fungible tokens has been the rage for the past year and up to the current bear market. So OpenSea itself is a marketplace. It also has all those smart contracts running in the background. That means it's somehow the app as well. It has its own centralized and decentralized stuff. But OpenSea is a marketplace for NFTs. That means you can buy, sell, trade these kind of images, NFTs on OpenSea itself. Then MetaMask, I just introduced. Okay, I think we can start the workshop first. So Brianna, do you need them to go to the GitHub link?
Yep, so I have shared the GitHub link and also slides to what Elson is sharing right now. If you would like to follow through or have a better understanding, you can also clone the GitHub on your local environment. Elson, your screen is a bit small. You may want to like expand a bit.
Sorry, the Zoom bar is blocking. Okay, so I believe Brenna has shared across this GitHub link. So this is the entire app itself. It's built in Vue.js. Vue is a front-end framework. So it's not particular to any framework. You can build it on React, you can build it on Angular, even you can build it on static. The important part is you need to install the ethersJS that is able to communicate with a smart contract. So this project itself also contains the contracts. So if you can see, there's bank to you, this solidity contract. Later on, we're going through this, and the app itself. So it's in SRC, app.vue. So this is a Vue application, Vue.js application. So I have written down some instructions that you can follow to install. So this is, everything is done using yarn or npm. So if you have npm on your machine, then you can use it. Hardhat itself can be also used with npm. So Hardhat, there's a few other steps as well. So you need to compile your contract. You need to start your local blockchain, and you need to deploy your compiled contract onto this local blockchain. So we will be going through this. Okay, let us look at our smart contract. Okay, before that, let me introduce this tool. This is Remix. So Remix is basically a web-based testing ground for your Solidity projects. So basically, you can write your entire Solidity smart contract here, deploy it, test it, and even deploy to mainnet. You can everything run on this Remix platform. So it's remix.ethereum.org.
Sorry, Elson, can you zoom in a bit on that thing?
Oh, okay, sorry. It's a bit small, right? Yeah.
Yeah.
Okay, so I will not be going through how do we use this tool, but let us go into our code itself. Oh yeah, before that, I can show you the application that we will be building. Okay, so our application is called Bank to You. So it's like Bank to You, but it's decentralized. So if you click connect to MetaMask, right? Oops, sorry, let me disconnect first because I was testing it just now. Disconnect. Okay, don't be shocked by the amount of ether I have. This is just testing ether. If I have this, I'm very sure. Okay, localhost. So I'm already running this on my localhost. It's just a Vue CLI project. So when I connect, right, you can see I can select my account. Next, connect. So once it's connected, I can see my balance currently in my bank account. So I can deposit and withdraw. It's very simple, just two functions. So for example, I wanted to deposit 2 ether. So let's see what's my account balance right now. It's 9998. So it should be go down by 2. So it's 9996. Deposit. So MetaMask will ask me for confirmation of deposit. So there will be this gas fee. So what are gas fees? So gas fee, you can acting as like a transaction fees because miners require to the nodes that just now I talked about, the computers running on the network, right? They need to earn something, right? You need to pay them a fee so they can validate is to incentivize them to validate your transactions. This is how the whole decentralized things works. Okay, so once we have this gas fee paid, we just click confirm. Basically, on Ethereum right now, the gas fee is not that high, but during the past few months, during the NFT craze, the gas fee is crazy. So for now, it's not that high yet, but locally it's very low because I'm running a local blockchain right now. It's a local Ethereum clone chain, I can say. Confirm. So successfully deposit 2 Ether into the bank. So it will refresh my balance. I can also withdraw this. So for example, I withdraw something much more higher, 4, but I only have 3 in the bank. So I will see a fail to withdraw. Basically, it talks to the smart contract. The smart contracts will block me to withdraw because I do not have enough balance in my bank. Okay. So what if I want to withdraw 1? So let me see my balance right now. It's 9996. So if I withdraw 1, it will be 9997. So withdraw. So again, MetaMask will ask me for my confirmation to withdraw. There will be gas fee as well. Deposit, withdraw. Any transaction will have gas fees. Click confirm. So successfully withdrew 1 Ether from the bank. So currently we are left with 2 Ether in the bank. Let us see our MetaMask balance. So we have 9997. So that's what we will be building. So let us jump right into the code. You can open up the code on your local or you just follow through. So I won't be going line by line like a hands-on workshop. That will be on another session. I basically just explain what are the things that you are seeing right now. Okay, if you look at the folder structure here, just now I explained that our app itself is in app.view. So this is a view application. So app.view itself has all this HTML code. I believe everyone here is familiar with HTML. So we have 2 form fields, 1 form field, 2nd form field. So the first form field here is to deposit. You can see you will call a deposit function in below. And the second one is called withdraw. So you will also call on click, it will withdraw the amount. So the withdrawal amount is bind to this view model. So I won't be explaining view architecture here, but for starters, right, we need to connect their wallet. So everything Web3 promises is like your identity is just your wallet. So we need to connect their MetaMask wallet. We'll be using MetaMask this round, but if you are using Wallet Connect, there will be another set of codes. So this connect wallet will call this function called connect wallet function. Sorry, my scroll is a bit. Okay, let us look at this function, connect wallet itself. So what are all this stuff? The first thing first, we need to check if there's Ethereum object injected. So MetaMask will inject this Ethereum object into our window. So we'll be using this to request MetaMask to do stuff. So this we set connecting to true. Then we execute this request accounts. So basically, it will tell our MetaMask, oh, this site wanted to connect to MetaMask already. Ask the user to pick the account. So in just now screen, we see that we have a lot of accounts that we can use, right? So once we've found an account, we will just use the first one. So this is an array. We put it into our current account. Then we'll execute another function called check balance. So once they log in, we need to return the latest balance in the smart contract itself. Understandable, right? Okay. So this is the deposit functions, and this is the withdrawal functions. Oh, I think I need to go through the contract first. Sorry about that. This is the front end application. So let's go back to the contract itself. So in contracts, we'll see here, contracts bank to you.so. .so is for solidity. So this is our entire smart contract. It's just that simple. So when we started to code solidity, right, this is solidity already. Yeah. So we need to specify the version that our compiler will be using. So currently we are using 8.0 and above. And so when we start normally in any object-oriented language, right, you have class. So in smart contracts, we have this contract. Then the name of your contract can be anything. So bank to you is our contract. And we have global scope variables and functions. So it's very object-oriented. If you come from Java, if you come from C++, everything is very familiar to you. So this is a mapping. What is a mapping? So we map an address variable type, a data type called address, to another data type called unique integer. So this is the variable name. You can name anything you want, but currently we need to track everyone's address, right? So whoever connect to our site deposit funds, we need to track who deposited how much. So basically, who deposited how much address is the wallet address. UINT, unique integer, is our balance. So once we did, okay, let us look at the deposit function itself. So deposit function, there's a few keywords here that you need to take note. So external, so this is the accessors. So basically you have public and private. I believe you understand public and private, but in smart contracts, right, there's two more. It's called external and internal. So if external, right, modifiers, this is access modifiers. So if you call an external function, it can only be called from the outside. There's no internal functions that can able to call this function. For example, I wanted to call deposit from withdraw. No, it cannot be done. It can only be called from the outside. So that's why it's called external function. And payable. So this is very important. If you were to pay, that means send funds, send cryptocurrencies into your smart contract, right? You need to have this payable. Okay, let us look at the function implementation. So we have this special function called required. So required, common sense, you know that we need to ensure that the deposit, the amount is more than zero. We won't let them negative value or zero amount to call this function. So MSG value, what is this? MSG is a global variable that is available for any Solidity projects. So MSG value basically translate to the amount that I'm sending into this contract. So just now I deposited 2 Ether. So this will convert to 2 Ether, then make sure it's more than 0. So we don't want them to send very small amount. So once we got this right, we will just increment the value from our mapping here. So our mapping is this. The balances is the variable name, then the address. Yeah, this is another global variable. So MSG, it has other stuff like sender. So sender basically returns the wallet address of the user that is interacting with your smart contract. So we just increment the 2 Ether that I just sent in to the balances. So the smart contract will remember that, oh, Elson just deposited this 2 Ether. So it will always stay on the blockchain, stay on the decentralized network itself. It won't be taken down. So this currently the smart contract will already have balance of 2 Ether because I just deposited in there. Okay, let us look at the withdrawal function. So withdrawal, we have 2 conditions. So you're curious, why do I need to use require? Maybe I can use if, and then I can return something. You can do that as well, but it's better that you write in this format. So because it will throw something called revert. Revert basically stops everything from executing after it clashes with the condition, doesn't meet the condition. So normally I would recommend people to use require instead of if, then you do a return or do a revert. So back to our withdrawal function, the amount. So we need to pass in the amount more than 0, of course, because we are withdrawing something, right? And make sure the balance of this user that is requesting is more than or equals to the amount. If not, basically you don't have enough balance to withdraw. We don't want them to withdraw more than they have. So on the balances itself, right, after we make sure these 2 conditions is met, we just deduct from the amount, then send them the amount. So this payable function and transfer function basically tells the smart contract, oh, you can now send to this wallet address the amount that they requested. Amount is passed in here. As you can see, there's no return or anything. Basically, it's just interacting with the smart contract memory. Okay, we have the third function here. It's called balance. So balance, we need to check for balance. Remember when we logged in, we do a check balance. So balance is also an external function, and the view. What is view? So in Solidity, right, there's a few functions you can type. So there's view functions, there's pure functions. So in this sense, view is only read only. That means any implementation in here won't modify the state of the smart contract. It won't modify the global variables here. So this is also for security reasons. If your function basically just read something from the global scope, you just use view. Then you can see I specify the return type here. So it returns a UINT, so unique INT, because our mapping here is using UINT, right? So we are returning a unique integer. So in this implementation, it's quite straightforward. We get the wallet address, put it in our balances, and we will automatically get the balance of this current address. So that's pretty much all of the smart contract itself. It's very simple. Okay, let us move back to the app that we left off just now. So the connect part, we already went through, connect our account. So let us look at the deposit function. Deposit function right here. So we are using this ethersJS library. You can see I have already imported here. So if you install my project using the npm or yarn, it automatically pulls down this JavaScript library. And I need to import this contract API. So whenever we compile our smart contract, right, using hard hat, it will show up artifacts here. So artifacts are required when you initiate your contract. So when we mount our entire application, this is view stuff, view architecture. When we mount, that means we load the page or something. We need to initialize the contract. So whenever we deploy our smart contract onto Hard Hat network, right, there's instructions on the GitHub repo. So when we deploy onto that, it will return a contract address. So you need to change this here. Your contract address might be different from mine. So, and also we need to load in the contract API. So contract API is loaded from this. It's a JSON file. So you can see here, when you compile that, automatically there will be these two files. So you need to import this. So this is contract API code. So basically the bytecode that is interacting with the Ethereum virtual machine. Okay, once we have this contract, right, we will assign it to our global variable here. I'm using object phrase because I don't want Vue to modify the contract on the code, because Vue is a two-way binding architecture. So I'm not go too further into this. But once we initialize, we can start using the contract already. So connect wallet, we already done. Back to deposit. Okay, deposit. So how do we interact with our contract functions? So if you remember just now, I already initialized my contract into this global variable called this.contract. Basically, I just execute it like this, very simple. Deposit, we call the deposit function. It must be same as what we type here, deposit function. So this is our Solidity contract. Exactly the same. It's that simple to interact with your smart contract on a Web3 decentralized application. Okay, so I pass in something called options. So options is basically an object. I need to specify from and value. So from who? From this current account. If you remember just now, when I logged in, right, I assigned the MetaMask return account into this global variable. So I just reuse it here. This is basically your wallet address. Then I will pass in the amount I want to deposit. So this form.deposit amount here is from the form just now we saw. Okay, so this is the form field for the deposit amount. So this is view model. That means it will bind anything returned here into this global variable called deposit amount. Back to our deposit function. So for example, if I deposit 2 Ether here, make sure you use password and convert to string, because it needs to be in string. Then use this Ether's utilities function to pass it as Ether. Because why are we passing as Ether? During our application, right, we only specify 1.0, 2 point something. So this is in Ether format. Ether has a few formats that's in way. That means a bigger format. For example, you have 2 Ether equals to maybe 2 billion way. There's conversion for it. So you can find the calculator there. It's either you're passing this, or if you wanted to pass in full ether, you just need to use this utils function to pass the ether. Okay, so once we got that, we need to deposit into our contract itself. So basically, this is a way the transactions to be done. Then you will say, oh, this already deposit into bank. If the deposit functions does not revert, remember about revert. Whenever the condition does not meet, right, it will revert telling that there's an error message, basically. So basically, that's all for the deposit function. Then let us look at withdrawal. It's also very similar stuff here. So basically, I just need to pass this as ether as well. So this is currently bind to withdrawal amount. So if I want to withdraw 2 ether from the contract, just pass in this here, wait for the contract to execute it, the transaction to be done. Then it will say successfully withdraw the amount that you want from the bank. That's it. So this down here, you just stop the loading and make sure the form field in front to go back to 0 for the withdrawal amount. So we won't let them stay there. Then for check balance is much more straightforward because we are basically just reading from the contract itself. We can call this contract function balance. Remember, we have this balance function here. So you just get this balance. So the balance itself will return in WEI, W-E-I, as I explained just now. So you need to format it back to ether to be able to display it, unless you just wanted purely to display as WEI format. So that's it. That's how the entire application, this is a fully decentralized application. You do not need any central server to store your balance data. You do not need any central authority to manage your funds or transaction. Everything is going through the blockchain itself. Okay, I think that's all. Brianna, maybe we can open up the floor for some questions.
Okay. Yes, we have some questions for you. But I'm not sure if you have walked through the entire journey of once the app is up, how does it look like?
Yeah, just now we showed about this app application itself.
Okay, so there are a few questions coming in. Number one is Jared is asking if there's any pros for using ether.js versus web3.js library in the workshop. Saw some web.js is commonly used for some tutorials.
Yeah. There's 2 popular libraries, web3.js and ethers.js. So web3.js is much more older compared to ethers.js. I personally like ethers.js. There's no pros or cons, but the functions, it's much more simpler to write. You can say they have a few functions, less code compared to web3.js. I tried both of them. In the end, I still choose ethersJS. But you need to know ethersJS, I think, is maintained by a single guy. Currently, is asking more maintainers to help him to manage the repo itself. So that part you need to be aware. For web3.js, it's maintained by a lot of people.
But in terms of functionality wise, like interactivity,
it's the same. It's the same. Yeah.
Okay. The second question is, how soon do you think, these are personal questions, how soon do you think that Web3 will become more mainstream than the current Web2?
It won't be so soon because we are currently at a phase where there's a lot of experiments. There's a lot of trial and errors. It won't be that soon because you see from internet 1.0 to transit to 2.0, it took I think 5 years time. So Web3 is still in a very infancy stage, I would say. So you won't expect to be too soon to take over anything. So you guys are considered the pioneers.
Okay. There are a few discussions on the gas fee actually, but if you have any pointers that you wanted to answer, then you can top up on that. So Xinhui asked, does it mean that the gas fee to be charged? Sorry. I think that's the follow-up one. The question that Xinhui asked was about if the gas fee is adjustable while implementing network, I think it will be.
Yes. You can specify your own gas fee in the ethersJS when you call the transaction, but normally MetaMask will recommend a gas fee, but you can specify a value when you're executing the options there. Let me go back to the code here. Okay, so here you can also specify the gas fee that you're expecting that this transaction will cost. Normally, what will I get? I will get the expected amount, then times maybe 1.2. This is for Ethereum network. But for other network, you don't need to worry about the gas fee because currently only Ethereum itself has very higher gas fee compared to other networks. So you can look more into the options available when you are calling a contract function. This is ethersJS function.
Yep. So,
okay, I hope that answers your question.
Okay, Grace has a question. I'm completely new to coding or web development. If I would like to eventually go into blockchain development, what languages are best to learn? Is Python used at all?
Yes, there's people using Python for it as well. Because Python has its own web development language as well. So I think it's the Django, right? Then you can use similar libraries as long as you are using ethersJS or you are mentioning about web, not web application. Is it desktop application or something?
She's new to coding or web development.
Oh, I see.
She wants to get into blockchain development.
I see. Currently, you need to separate a bit on blockchain development and this decentralized app development. So blockchain itself, maybe it's the hardcore, creating the entire Ethereum network. But we are looking at decentralized applications. So decentralized applications are applications on top of blockchain. So we are currently looking at that layer, the application layer. So if you would like to get into this development, I recommend you get started with web development first. Get to know how to create websites, how to use this library ethersJS. Then slowly on, you can able to pick up this dApp development.
Yep. Thanks, Elson. There's one interesting one. Jerry is asking, for Web 2 and Web 3 apps, how much differences is the infra cost for similar purpose applications?
Infra cost. So if you are getting the centralization out of the way, that means you have centralized databases. The running cost for centralized databases basically gone. You rely on the blockchain memory itself to store your data. So there's not much infra cost you use when you are using the apps. So maybe your static website, the dApp HTML code that use ethersJS is deployed on something like Netlify. You can basically run it for free. And basically what user interacts with your dApp, right? They need to pay the gas fee, that's all.
Yeah, if I can top up on that also, if let's say your apps, I guess we also need to define a fine line of Web 2 apps and Web 3 apps, right? Like what do you mean by Web 3 apps? Because right now the dApp decentralized app, like what Elson rightfully say, we are building an applications that is interacting with the network. We are not building any new network like the enterprise nodes or having different nodes for us to build the network. We are building the application that leverage on some of the public networks that is running right now. In that sense, you will have to decide how you want to host the entire infra of your apps, whether you are using AWS serverless or you are using like what I also mentioned, the Amplify, or you are just throwing it onto S3, right, bucket. So that cost will be the solution architect will have to decide how you want to minimize that cost. Next, okay, Hafiz is asking.
Yep.
Can we use Ethereum for IoT? Maybe I will expand it a bit more, not to just Ethereum network, but I mean blockchain. If yes, how can we use it? Is there any specific tools or library, etc.?
Ethereum is not purposely built for IoT applications. I remember there's another IoT blockchain built specifically for it. Forgotten the name already. Maybe I will look it up. Or you can just join Cryptocurrency group and ask the developers there. There's a lot of good developers on the group itself.
I think.
Oh yeah, Helium. Yep. Yep. Correct.
Okay. Thanks. Adirin, what are Web3 cybersecurity risks?
Web3 cybersecurity risks. So as I mentioned, the smart contracts are all immutable. That means you cannot change it once you deploy onto the network. So any bugs, any code bugs that you didn't really go through well, it will be forever there on the blockchain. So people can exploit these bugs.
Okay. Grace is asking, if NFTs are stolen on platforms like OpenSea, is that because the dApp security issue?
OpenSea itself, they done a quite good job at auditing their smart contracts. So the most cases of being stolen is human factor. So there's a lot of social engineering going on. They basically steal their private keys to their wallets through social engineering way. That means the human factor there, you get scam, you get your account password you did not set very strong, easily leaked or something. Then that's most of the exploits are happening this way.
Yep.
Yeah, I hope that answers your questions.
Yeah, it is. Chua Zhong is asking how re-entrancy attack in smart contract works. How can we prevent it?
Okay, re-entrancy attacks, right? It's basically you minus the amount before you do something checking. So that's why I'm asking that you guys put the condition checking first before you do any state changes. So that's one way to protect yourself against re-entrancy attacks.
Elson, maybe if you could, can you explain to newbie like us, what does it mean by re-entrancy attack?
Okay, re-entrancy attacks basically means, how do I put it? There's another, you can build another smart contract to interact with your current contract, or people can just call your functions first because you are minus, for example, I put this here. I can directly withdraw the amount, the amount that I like. So normally I would recommend people just to check your condition first before you do any sort of state changes.
Does that mean draining the entire?
Yeah, it's basically draining your entire smart contract funds. Yeah.
Entire funds lah. Oh, okay. I think for a bit of context, that would mean that someone is attacking your contract by withdrawing all the amount that is all the money or that's being stored in your contract. And then Elson was suggesting that we need to put that required condition, meaning check that the user actually have the amount that they want to withdraw seated in the contract that belongs to them before allowing them to
before you change the state. Yeah.
Okay. Next, Yi Hong is asking, how would you patch a security risk on a published contract?
Okay, there are upgradable contracts. So I see someone's posted the Open Zeppelin documentation. So basically, upgradable contracts are contracts that are able to change where are they pointing to. So if they're pointing to contract A, your contract A has a bug, you just change the pointer to point to contract B that is already fixed the bug. But it's very not good to do this way because investors that are using the app, the users will not like it. Oh, this is a upgradable contract. So they can change it to anything they like after they, maybe you can call something like doing something like a rug pull. So in rug pull in crypto sense, that means they can easily take all your funds out and disappear.
Does that mean that the contract is not being stored in a blockchain because we know that it's immutable?
No, actually you deploy an upgradable contract it's like a pointer. If you're in C++, there's pointers, right? So if you point to another contract, you deploy basically two contracts. So the current contract is pointing to contract A. Then once you found contract A has problems, you point it to contract B. So contract A is getting rid of. So basically it's not exactly an upgrade, but like a change of the latest contract.
So that means that in my dApps, I will have to change all the pointers, right? Like to point to the new contract.
Yeah. It's in simple sense, that's how it works.
Okay. Thanks. The next one, Jaden is asking, when we are trying to mint an NFT project, we shall require to connect wallet for the minting website. Just a bit of context, minting NFT, that would mean in layman terms is you go to that project and say you want to buy the NFT.
Yeah, buy.
And minting usually is like at the starting when they set the day saying that today we launch, right? Everyone just rush to their website and start buying that thing. And to buy, you will have to connect your wallet. So his question to you is, how does we secure ourselves from being stolen on what's on the wallet?
Okay. First thing first, when you mint on site, you must make sure the contract address on the site is valid. So there's this etherscan tool. So if you are doing on Ethereum network, is the block explorer. That means application online that you can see all the transactions and all the blocks information on there. Basically, you just make sure the contract address on the website is correct. When you mint, right, MetaMask will also show you the contract address. So you can double check there as well. As long as the contract address is the valid one as advertised from the NFT project you are looking at, then that's one of the methods to help you to reduce the risk of being stolen from your wallet. So second thing, just make sure your wallet you are using is a hot wallet. It doesn't have any much funds in there. Maybe you are minting a 0.5 ETH project, NFT project. So just top it up with the 0.5 and plus some gas fees. Don't put all your funds in your MetaMask wallet. That's the security risk there if you put everything in your wallet.
Yeah, another one is do your own research and due diligence on the project that you are minting. Make sure their contracts are being audited by certified security parties. Yep. Okay, the wiki from PathDAO is asking how to balance immutability and human errors. Say devs made some errors during smart contract design, but only realized post deployment.
Very good question on this one. You really cannot find the balance here, I would say. So rigorous testing and smart contract audits is part of the development pipeline that you need to put into your project. So to reduce as much human errors as possible. There are also testing tools that you can run attacks against your smart contract. You can use that as well.
Yep, I think that is all the questions coming in. We actually have a bit of time. So audience, if you have more questions, you can keep coming. Or Elson, do you have any things that you have kept in your pocket that you wanted to share now?
Yeah, so there will be resources for further reading and also the GitHub repo link in the slides. So you guys can explore the extra resources here. So more on explanations and the official documentation of Hardhat. Their documentation is quite well done. So you can see from installation to how to use it and ethersJS. Yeah, I think that's all from me. Is there anything you'd like to add?
Okay, that's all. Joe is asking, you mentioned a hands-on workshop in the future. Would that be in-person workshop or is that an estimated date? So maybe I'll take on that. We are exploring potential, making this as a series, but it would be depending on the interest. So later on, I'll be submitting I will be giving out a feedback form as part of Carrot. I have put that question as the last question. So If you guys are interested to have really like a workshop, especially getting Elson to walk through the entire solutions that he has built, please fill out that feedback form and we can arrange that. So Jill, make sure you put in all your requests in, and then we can also, and the feedback. For the slides, Karen, let me just share it again. So any other question for Elson? I'll keep 30 seconds on while I'm sending the link to the slide again.
Yeah, everyone go join CryptoKaki on Facebook.
Can you flash it out again, the link?
Let me copy the link here. Okay.
Yeah.
So this is a group for the techies, the developers, and anyone who is interested to learn. So our group is not that kind of group that shares a lot on trading, on those buy calls. You won't find those kind of stuff in our group. It's mostly technical and news regarding the technical side. I think there's another question. Ethereum and other smart contracts platform.
Yeah, Sana is asking, what are your thoughts on Ethereum versus other smart contract platforms? How do you think these would play out? Would we have different smart contract platforms for different use cases, or there will be a consolidation around one platform in the future?
I see. I don't think there will be a consolidation that soon, because currently there are a lot of other smart contracts platform out there. There's even different blockchain languages, like for example, Solana has its own smart contract, which is coded in Rust. Then we have layer 2s. Those layer 2s, you can look it up online. So layer 2s are like fixing what Ethereum is called currently bottlenecking. That means the gas fee is too high, the scalability issues. So you can look into Polygon network as well. Those is newer networks. So they're trying to fix it. So I would say at current stage, it's like a battlefield for all of these L2s or these different blockchains, that who will be the dominant. But for myself, I believe Ethereum is still the last one standing for smart contract development, because he's the one who started, as long as they fix the scalability issues.
Just curious, right? L2 layer also, let's say Polygon and many more, right? They also relies on the Ethereum chain, right?
Yeah.
Okay. Last question for Adri. In your experience, right, are smart contract more error prone than normal software?
Normal software, no, I think most of the errors are coming from humans. The language itself is very type safe. You can see there's a lot of declaration of different access modifiers, the private, the public, the external, the internal. There's also view and pure functions. It's how you code it that makes the smart contract secure or not.
Yep. I think that's all. We will have to close the Q&A. If there's any more, we can answer it later. Elson, can I share my screen?
Yeah, sure. Let me stop sharing.
Yeah, so I will have to share my screen so that I can get feedback from everyone, that to know what you guys are interested about Web3 topics, because we have a lot to cover actually. So this is a feedback form. Please let us know your thoughts on the feedback, on this event, and what do you want to hear from Women Who Code? If you want the next blockchain, please mention it into the feedback as well. I'll leave these slides on for a while I turn off the recording.
Thank you, guys.